Hello, everyone. Welcome everyone to the last workshop of day 3 of the yuHacks workshop week. Thank you for tuning in, and a big thank you for all the people who've been tuning in for all of the workshops today. It's been a long day, but we're really excited to bring you another workshop, which is about it's going to be introduction to Arduino using TinkerCAD. Today I'll be joined by two lovely workshop leads from the York University Robotics team, Luke and Mastafa. Let's welcome both of them on the stage. How are you guys?
Hello,
Doing good.
Hey
I'm
guys.
Mastafa.
So why don't you guys give us a short introduction about you guys first?
Sure. First, hi everyone. I'm currently the rover team lead at the Robotics Society. Let me just share my screen real quick. Oh,
Yeah, and I'm Luke, the Sumobot team lead here.
Awesome.
so just not sure if the sharing screen is working at the moment, but basically, I'm not sure if you guys can hear me because my the window froze.
We hear you.
Okay, perfect. So basically, at the Robotics Society, we basically have two teams, the rover team as well as the Sumobot team. The rover team basically works on a much larger rover, about 50 kilograms in weight. And what we do is we basically make a teleoperated robot that has some autonomous capability to be used in competition in Alberta. We generally try to go every year, and this is the project that you join if you want to work on a large robotics project at York, basically. The other team that we have is the Sumobot team. The Sumobot team is led by Luke, and we basically make palm-sized robots that fight each other autonomously. And a big part of both of the teams is actually controlling motors. And today's workshop is just going to be a quick introduction to Arduino, which is a microcontroller, not the one that we use on the rover, and but it's the exact same one that is used on Sumobots. So it's just going to be a quick little workshop to show how to use an Arduino to control a motor, just like you would in real life. So I'll hand it over to Luke now.
All right.
Thank you for the introduction, Mustafa. All right,
Yeah,
so
so
without further ado, yeah, I'll pass it off on to Luke and enjoy, everyone.
let me share my screen here and see how well this goes. And let's see, and okay. I hope you can see this. Whoa, okay, definitely can see it. All right, let's start from the top. So a better, of course. Okay, here we go. So from the top, Sumobots, right? This club is really about, as we described earlier, building those palm-sized robots. And they look like this. They look like this beautiful little image right here. And the idea is that you build these robots straight from scratch. You build the structure, you design the circuitry, you write your own code and everything, and you basically learn the basics. And if it's too easy, you can simplify it, you can remove features, you can use some of mine, and you can steal some of my own designs that I provide for you guys and whatnot, wherever you kind of lack, so you can, meet deadlines and whatnot. And the competition is supposed to be held at McMaster University in the winter semester. That's tentative. I see the date is wrong. It's supposed to be 2022, but due to regulations and whatnot, it will probably not happen. But we are looking towards hosting a competition for all the members here at York instead. So more technically, how big are these robots? They're 10 centimeters by 10 centimeters, and they're autonomous, so you don't remote control them in any way, shape, or form. And they serve to fight these other bots, basically. And the end goal is that they move around a ring, basically. And I explained earlier they're programmed and built by you. and a quick little demo. This is kind of like what these motor drivers and what we're going to discuss is kind of serve, right? And you can see that bot there in the video is here. So moving down the line, we can discuss, they're usually bi-weekly meetings, and we have been hosting them since September, and we've covered a lot of content. So we've covered all of the tutorials and stuff in the fall semester, and now currently it's a lot of in-person office hour type, online help kind of sessions to help you get up to finishing your bot now that all the content's out there on YouTube that you can watch at your leisure. With screen shares and PDFs and code, and everything's all linked in our Discord, and everything is all set up for you guys. I leave this up to questions if anybody has any. I don't know if the software has the capability of people asking questions, but if you want to relay any to me, feel free. But if not, we're going to jump right into this amazing tutorial, and I'll show you guys exactly what to do. Basically, we're going to try and build kind of like the circuit that goes along with building these bots up to, not building these bots up, but building like the main kind of part of the robot, which is the motors and the Arduino controlling these motors. So let's start with this tutorial. So I am going to close these slides because we need to jump into our PDF that I provide to everyone, and I will also have a link, and I assume this recording will also have a link in the description somewhere as well. So let's jump into that. Let's copy this link here. Let's paste that in our beautiful giant. I don't know where I can post this publicly, but it's there. And it'll open up this amazing PDF. We'll also put these slides to the side as well. So what are we doing? We're basically using this software called TinkerCAD to make your circuit digitally. So we don't even have to touch any real circuits. No electrocuting yourself, even though it's like a minimal risk. Nothing like that. All we're doing is making a simple circuit online, and we'll even spin the motors digitally. And you can literally copy this wiring to the T with some, minor like reality checks and stuff, and literally implement it into your bot. And we've done that in our tutorials and whatnot. So first and foremost is we need to create an account. It's as simple as that. TinkerCAD is very Googleable. So TinkerCAD login. For me, I've already created an account, but we can just sign on. I can sign right on in, and we'll be ready to go. It's going to hit me with the verification code. Okay. Amazing. So once you've created an account, you're right in here in the Autodesk kind of TinkerCAD, kind of this is your main window. But since we're creating a circuit, I should preface, TinkerCAD, you can design circuits, you can design code, and you can design 3D models for things. Example, your Sumobot base, if you didn't want to move to Fusion 360, which is the software you usually use in our tutorials, you can make more simple stuff like quick, easy stuff in TinkerCAD, and it's kind of handy for that reason alone. So what I need to do is, of course, create a new circuit. So if I click on circuits, none of these would show up for you. These are just examples that I created over time. We're going to create a new circuit. And this I'm going to be following along with this PDF on the left side here. And you can see once we click create a new circuit, we're going to have this kind of playing field, basically. This is kind of your work surface, I guess, what I called it here in the tutorial. So this work surface is where you kind of lay out it's your desk. You get stuff out of your box, you get stuff out of your Amazon box, and you place it on this table. And this is where you kind of connect everything. And this is your Amazon box of components on the right side here. So what we first need to do is change the view so we can see everything, and change it to all components instead of basic. So we can see here all instead of basic. And we need to search out these 4 components because this is what we're going to use. And I'll explain each component on its own so it becomes very clear what each one does. So the first one is the Arduino Uno R3. This beautiful little thing right here, some of us probably already know what it is. It's been used many, many times before. All it really is a little computer, a very, 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 very low power computer, and it runs its own code. Once you've programmed it, all you need to do is hook it up to a battery, and it'll just run code and do things for you, which is pretty handy. So this is what we're going to be programming using this built-in tools, very nice tools in this TinkerCAD software. So I'll explain more as we try and code this thing, but we also need a 9-volt battery. This is because, it doesn't like that. Battery. There we go. And I can just click R on this. I'm pressing the R key here to get it into a nice position. 9-volt battery is because this Arduino runs on 5 volts, but it can't supply enough current to power the motors. The motors can technically run off of 5 volts, but even then, the Arduino just doesn't have enough juice to power these motors that we're going to use, which is the next thing we're going to look up, which is the hobby gear motor. I don't think when I'm showing my screen you can see my camera, but if you can, I have one right here. They're quite large, but for a Sumobot, you can just barely get by with their size limitations. So the last thing we need is a chip, a very fancy chip, a very useful chip. It's the L293D. And this is where the stuff gets fancy, because this basically puts all these other 3 components together on our kind of board. It kind of connects everything. So what we need to do, of course, is to connect everything. So this L293D, in essence, is a motor driver. It kind of shows up like such. It's a little, maybe I can find one on Amazon really quick because they quote Amazon. L293D. They're everywhere. Some look like this. They seem to have changed the design slightly. You can buy just the chip on its own, and this is the one we've mostly been using for tutorials. It just looks like this. It basically breaks out this chip into a million different ports, much easier to wire. You can wire it using a screwdriver and some wire instead of anything fancy like a breadboard or anything. Quite handy for that reason. But we need to wire all of these up. And I'll explain why you wire the things that you do as we go along. But what we can say is it'll take the power from the 9-volt and it'll take the signals generated by the Arduino and it'll turn the gear motor. That's kind of our flow. So as we move along, we can see there's this amazing feature in TinkerCAD. Let me zoom in a bit. Hopefully make it a little easier to see. And we'll shove this tutorial over a bit. We don't need that. That's big. We can see if we hover over these pins, it'll actually tell you what they are, which is very, very handy because otherwise we don't know what we're wiring to unless we go into deep down into documentation that nobody reads anyways. So we can see that there's grounds here, and there's also outputs, inputs, and enables. So, and there's also power 1 and power 2. Let's start with easy stuff, ground. In summary, you'll wire all the grounds together, but you can also assume that if a chip or a component of any sort has multiple ground ports, example, there's ground here, there's also a ground here, but there's also 4 grounds on this chip. You can, 1, wire them all together, or just wire to a singular, and they're connected usually internally. Usually I say it like 99% of the time, unless you're dealing with like RF circuitry or fancy dancy, fancy stuff. You can assume they're all connected internally. So I'm going to wire all the grounds together. In this case, the 9-volt battery needs a ground. Look at that, pretty. How did I do that? Let's back up. All I did was click on the negative here of the battery. I clicked once, I let go of my mouse, and then I clicked again here. And then boom, it's connected just like that. Can we change the color of this? I want to change the color of it, black, because it's ground. So let's do this ground here. And now I'm clicking again to add little bends. So it's a little bit nicer looking, I guess. So we can see that and that there. So we've got a ground going to our Arduino, and we got a ground going to our 9-volt battery. And now we need to wire up our, I gotta remember here, our power 1 is basically goes to our Arduino, and our power 2 is basically what powers the motor. What voltage or what device do you want to power the motor with? In this case, I want to power it with this 9-volt battery, so I'm going to connect it to power 2. Let's make this red, so we can see that there. I think there. It's going to make it look prettier, but it's okay. And then power 1, we're going to go all the way down to our 5 volts here. So this 5 volts is basically, the Arduino communicates using 5 volts. Basically, all of the signals are within a 5-volt range. They vary from 0 to 5 volts. And this 5 volts helps this chip understand what counts as 5 volts. It doesn't know what 5 volts mean, so this kind of helps it sync up, and it also supplies a little bit of power to supply the internal circuitry inside. So what we also need to wire is the other signals going to this chip. So what's a little confusing about this chip is that it can actually control 2 motors. In this case, we're only controlling 1 motor. And when I say control, like we're supplying power, it can supply power, it can turn power on and off, it can vary the power, and it can also make the motor turn back and forth. That's what I mean as in kind of control the motor. So I need to wire up the enable 1 and 2, the input 1 and then the input 2, here it is, to the microcontroller here. And then I need to wire the output 1 and output 2 to this motor. And basically, this will do all the translation of the signal received by this to make this spin. So let's do that. Output 1 and then output 2. There. It doesn't matter if we switch the positive and the negative. If in a DC motor, if you switch the positive and negative, basically the direction just reverses. Nothing crazy. In this case, usually if you're building a Sumobot, you don't know which motor is supposed to spin until you try it. Nothing too crazy to figure out though. You can either change it with code, or you can just flip the wires. Nothing crazy. Oh, it's not letting me. There we go. I wanted to make these wires green and green. Beautiful. And now we're going to wire the enable 1 and 2, the input 1 and 2, input 1, input 2, and then enable 1 and 2. If you wanted to wire up a second motor, you would need to wire up the input 3 and input 4, output 4, output 3, and enable 3 and 4. That's all for the other motor. But in this case, we're just doing 1. So I'm going to cheat and look at my code to figure out which pins go where, because it's kind of dependent on the code that you write. A little bit of this and a little bit of that, and I'll explain why. So I'm going to put enable 1 and 2 into pin 9. And we can see these are all on the digital side. You can see digital, or in brackets PWM with a tilde. And then there's also analog ins over here. We're not going to use analog in this tutorial at all, but what we need to do is wire up to digital, and you can wire it to any pin you want. You just need to adjust the code, except One condition is that you need to wire the pins to these tildes here, specifically these tildes, because these pins have this little extra special feature in them that I'll explain in the code. This feature allows you to vary the power digitally. Basically, you can create an analog-ish output by rapidly pulsing on and off, and it's quite a fancy feature. So I'm going to do an input 1 to pin 5 here. Oof, it's looking ugly already. And then input 2 to 6. Oh man, it's looking extra ugly, but you can kind of see the connections. Let's try and clean it up a bit. I'm going to make these yellow because they're all signals. It's ugly. Ooh, it's ugly. And there's no way, there's too many crossed wires. It's not going to happen. Okay, so now we have everything wired up, basically. It was as simple as 3 signal wires, power for the chip, 2 different types of power, and then outputs to the mother. Simple, straightforward. Now we need to write the code. This tutorial is, if we were to teach you guys how to code in Arduino C right at the second, we would need an extra 3 hours. But we don't have that much time. So I'm providing the code, and I'm going to explain the code as it goes along. So here we go. We have basically the code here is provided in this tutorial. All it needs is a little bit of fixing up because copy and paste in a PDF doesn't work that great. But I'm going to copy it, Control C, and then we're going to come over here up to this top bar where we see code, start simulation, and all of this stuff. And I'm going to do code. I guess I should, can I zoom in this web page a bit? It might help. Of course not. There we go. I'm going to press on code, and then I'm going to change this blocks here, because this is for writing in basically Scratch language. Maybe you've done that in middle school. It's a really good intro into coding, but we're going to move up to text. And we're going to press continue, and now we're in text mode. And this is where I can paste my text. I can delete all of this crap, and then paste our code. Technically, this code will work if we run it, but it looks a little ugly. So I'm basically going to clean it up so it's a little easier to explain by just adding a couple of tabs here. Here we go. You can see our define statements up here. And there we go. And we can break it down a little bit. And there we go. That is basically our code as it stands. Basically, this code has 3 parts. 3, like, big meaty parts. The first part is a little bit of superficial setup stuff, basically. These statements are basically find and replace statements. Find this, motor A, anywhere in the code. If this piece of text appears anywhere in the code, replace it with 5. Because that 5, if you notice, coordinates with the 5 right here. And then motor B, replace with 6. And see how that 6 goes right there. And then anytime you see enable, it goes to 9. And we can see that appearing right there. And there, you know, input 2, input 1, enable 1 and 2. In case this, I just used A and B here, but same thing, basically. So that's the first part. It's kind of like how we define where our pin, what pin numbers we're using, and why do we, you know, plug them into here instead of 3 and 4. If we change to 3 and 4, we would just put 3 and 4 there. The next part is our setup. So this basically, any code inside of this brace here, and then this brace here will run one time. It'll go this line, this line, this line, this line, this line, all the way down. ignoring the comments, which are in orange. But it will go down all the way, which is great. Very simple, very straightforward. And we deliberately put this code here because we want it to run once, because what we're doing here is configuring. We're saying, what do we want these pins to do? Like now we have these pin numbers, right? And now the question is, what do you want to do with them? Because by default, these pins act as inputs, basically. If it sees 5 volts on the pin, it'll show you a 1. If it sees a 0 volts on that pin, it'll show a 0. But in this case, we want them to act as outputs. We want this controller here to send voltage signals to this chip. So that's what these 3 things do. And we can see motor A, motor B, and motor enable reappearing here. We want motor A, this pin here, which is replaced as 5, to be an output. Same with B, and same with enable. And then by default, we write the enable pin to high. So this is a command where we actually control the pin. And since we don't really care about the enable pin that much, all we want, basically, in our code, we want the motor to run all the time, basically, or at least the chip to be active all the time. We just, by default, enable it high, and then the rest of our code, you'll never see enable be controlled again. So it'll just stay enabled until we tell it not to. So we can see digital write, enable, high. But if we wanted it to be low, or 0 volts outputted by this pin, we would write low. Simple as that. So next on to the last big, the meat of the code here, which is the loop. So inside of these braces here, this line, 16 and 32, this code will run over and over again. It'll run 17 all the way down, one at a time, and then at line 32, it'll jump back up, and line 17, 18, 19, and basically until you unplug the microcontroller or reprogram it with something else, or it crashes or something. But otherwise, all things considered, it'll go over and over and over again. And it runs really fast. If we don't put any delays or anything, or tell it to slow down or anything, it'll run very quick. It'll probably run about 1,000 to 10,000 times per second. It'll get through this loop very quickly. So what we need to do is first tell the motors to spin. And scrolling down here, we got a little cheat sheet in our tutorial, because reading data sheets is a pain. So I've kind of done all this heavy lifting already. So we can see there's this little table. If you probably noticed, it was kind of weird that we had 2 pins to control the motor. It's kind of weird, because you think turn the motor on and off. But since this motor controller allows you to turn the direction, we need to be able to do funky things. We need at least 2 data lines, basically, to be able to do that in a digital sense. And this is basically how it works. We can see our action, what do we want to do? And then what do we do to pin 1 and pin 2? In this case, it's arbitrary. I'm referring to input 1 and input 2. So in this case, pin 5 and 6 on the Arduino, or motor A and motor B in our code. So if we set both to low, we do a digital write to motor A and motor B as low, it'll be stopped. Basically, the motor won't spin. And if we do both of them high, the motor will also not spin. But if we do 1 to high and 1 to low, or pin 1 to high and pin 2 to low, then the motor will spin in one direction. In this case, it's arbitrarily defined as forward. And then if we want to move backwards, we got to go in reverse. Or, sorry, start again. If we wanted to go backwards, we need to switch the pins, basically. So pin 1 is now low and pin 2 is now high. And how we're going to do that is some fun, basically. We're going to use, instead of digital write, we're already just going to jump right ahead and do something called analog write. Analog right is where this whole PWM thing comes in. So this whole PWM thing basically comes in the sense that we can control basically how on this motor is by pulsing. And we can show it here with this little graph. So on a number from 0 to 255, don't concern yourself too much with why it's 0 to 255 at this point, but on a scale of 0 to 255, you basically control a waveform like this that's being sent by one of these pins, basically. So we're basically going to switch rapidly from forward to stop, from forward to stop, from forward to stop, like thousands of times per second. And we can see this, and it's going to go like this. It's going to go on, and it's going to go come off, and it's going to go on, it's going to come off, like that. And we're going to use that command instead of digital write, because if we did digital write, it would basically be 100% power to this motor, which would be insane. In most cases, you don't need full power. I mean, you can write your code to use it, but consider that the motor will run faster and blah, blah, blah. It's up to personal preference, but it's really, really nice to have the code decide how fast the motor spin and not some arbitrary decision you made 2 months ago about which motors to buy. Because, oh, it sounds like the good speed that they can run at. So my code here, we can see motor A, this pin will run at 0. So it'll basically be low all the time. And then we can see analog write, I'll write to motor B at 128, which is in this case 50% duty. You can kind of think of it as 255. If I put 255 there, that's 100%. That's basically the same as doing digital write enable or digital write high to whatever pin, in this case motor B. Same thing. But in this case, I just want to run it at half speed, so I'm just going to do 128. And what this code is going to do is do exactly that. And then it's going to wait for 1 second. And then you see I'm going to do analog write both pins to 0. And that's going to stop the motor completely for 1 second. So let's give it a shot. I wrote this code a year and a half ago, and I think it hasn't failed me yet. There might be a typo, but we can find it pretty quick if there is, and it's actually an interesting debug procedure for sure. There's no bugs. So you can see here, the motor is spinning. We can see negative RPM. It's actually running backwards. And then it'll go to 0. It'll go up, and it'll go to 0. And we can see it's about negative 120 RPM. So if I change this, if I stop the simulation, change this to 255. Oop, it didn't like that. Okay, 255. And then we start the simulation. We'll see it go negative 250, 244-ish RPM. It's like double the speed. You can kind of see there's maybe a resemblance to these numbers. There's no resemblance. Kind of ignore them. So the motor's working. It's just doing it in negative. But if we wanted to change that, what I could do is swap this 255 to 0 and swap this 0 to 255. And we should see now that the code, and now that we've reversed the direction, see we've changed this in this graph from the forwards to the backwards kind of position. Again, arbitrary which direction is forward and which ones is backwards. But I've swapped that around. Now we should get a positive number here for RPM. Boom, positive number. So that, in just ultra speed workshop, crash course, everything, is how you set up a motor to work using an L293D controller, which is very common. And what I can say is, let's say for some reason you decided, I don't want to do Sumobots, but I want to join the rover team or anything like that. They use completely different motor controllers. But a lot of motor controllers work similar, if not somewhat related, to exactly how we discussed. You know, some might use some kind of fancy library where instead of analog write, you might use something, a different command. You know, and you interface that way, but a lot of them, you simply add these two wires, and it's dirt simple to control these DC motors. And I should say, you can also hook up any DC motor that you want. If you find any old DC motor, as long as it can operate at 9 volts or whatever voltage you supply here to this power 2 pin, it'll work perfectly fine, which is really, really great. And you can see how the simple application here can, you're covering so many different use cases that are quite common in the whole mechatronics kind of area of engineering. If nobody has any immediate questions, I think we've covered everything. Should I attempt to touch at the second motor? Should I do anything crazy? Do we have time for that? I don't know. Let's see. Is there anything else I can add? This is where I'm hoping you guys can chime in here, help me out. I think we've covered everything from front to back. And that is TinkerCAD. So we have time. Oh my God, I can see it in the chat. Okay. Sorry, I could not see the chat at all when I was sharing. Okay. Let's do this. Let's hook up a second motor and try and write the code. We're going to try and write the code and everything. Okay. I started sharing my screen. Hopefully it'll show up. Okay. From the top, guys. Well, not from the top. Continuing on. Let's ride this motor. Okay. So it's quite simple to wire it up now that you've wired it. Before adding to the code is a little dicier because there's options, and that's the whole thing about writing code, is that you have options. So let's set up another motor. Let's rotate it so it's not off screen. And let's run with this. So output 4 to 1 pin, and then, not input, output 3. Let's do this. Let's do this. Turquoise, because that's what I'm feeling like today. Grounds, remember how they are common, and they're already connected to everything else, so we're good there. Let's do input 4. Let's pick a new pin. We can pick pin 3, 10, and 11. So let's pick pin 10. And we're going with 10. Come on, let me add a joint. Looks so ugly. Okay, input 3, pin 11, and then enable 3 and 4 we can do to pin 3 here. There we go. Selecting is a little weird in TinkerCAD, that's for sure. Okay, selected all 3, and let's do purple for these ones. So ugly. Trust me, the professionals do not use TinkerCAD, but that's okay. It's a really useful tool for learning. If you're curious, some of the software we use is honestly not too crazy far off of this. Just a little less pretty. As I'm remembering from some of my labs that we've used to design circuits. There we go. Not that the prettiness actually changes anything, but there they are. Now let's do some coding. So we need to add on to these define statements, and you can probably, this is a fun procedure. It'll help you kind of figure out how C code works. I kind of interchange Arduino C and C code. They're almost the same, but there are some variations how they work. Arduino C is very close to C++ rather than C. But we'll leave that up to coding classes and other stuff to explain that more in detail. So let's do motor C, and then we're going to do 10. Oh, we're going to copy and paste this. We don't need any of those comments because we already know what these do. There we go. And now we're going to do 11 for motor D. And then we're going to do enable B. And we're going to do that 2, 3. Just like that. And bada boom, bada boom, we got that first kind of chunk of code done. Now we got to move on to the second where we set up. So this is where we set our pin modes. So we need to, of course, set all our pin modes. So I'm going to copy and paste these and just simply edit them up by just using a little bit of copy and paste. You see motor C, motor D, and then enable B. See, we're kind of adding on to the code. You can kind of see the pattern if you read it closely. How it's very similar just to add a second motor. It's just a whole different set of pins. So we also need to write the enable pin high because we want the chip to be on and working for the second motor all the time. So we can just do this. Oops. Control S habits. So now we need to go into the big meaty chunk. And this is kind of where the kind of options kind of bring. This code here will turn on the motor for a second and then turn it off for 1,000 milliseconds using this delay statement. I don't think I explained that before, but the delay statement will delay in units of milliseconds and then move on to the next line. It'll wait here, basically. So to add this motor, ideally, in a robot scenario, you would spin both the motors at the exact same time. And, you would run sensor data, you would pull some sensor data and see, what sensor data comes back and then do something based on that sensor data, whatever it may be. And then, turn around, do some fancy maneuvers or something like that. In this case, I'm going to just do a little, it's kind of like a demo thing. So what I want to do is turn on motor A, or the first motor, I should say, so we don't get it confused with this. Turn on the first motor, turn off the first motor, then turn on the second motor, then turn off the second motor. That's how I want the code to run, kind of creating an image in my head of what I want it to do. So turn motor on, here, the first one, then turn it off. And now what I'm going to do is turn the second motor on. So I'm just going to, instead of copying and pasting, maybe it'll be easier if you watch me write it. Analog right. And then we're just going to, first we write the pin number, which is motor C, comma, our number. Remember up here we did 255 and 0. Let's do that again. 255. You know what? Let's do 240. Feeling a little spicy. And then I can write that all again. Usually when you write code, it's a lot of copy and paste it. Let's be honest. I'm just writing it so you can kind of see the procedure in which you would normally kind of write that first line of code to look like. And then this one to 0. And then we'll do another delay statement here. Oops, forgot my semicolon. Every single line of code should have a semicolon. Some exceptions apply. Example, you're putting a little swirly brace here to open up this loop and close it here. Analog or right. Of course, I can't spell right to save my life. And now we're going to delay by 1,000 milliseconds or 1 second. And then we need to shut this motor off somehow. So we'll just do a copy and paste this time. There we go. And now I'm going to set them both to 0. 0 and 0 for C and D. So this is all for the second motor. We can second motor. And now this should work like a charm. It'll turn on this motor for a second and then turn on this motor for a second, but never at the same time. 244. Negative, because it's going in the opposite direction, but whatever, because we switched the, in this case, output 4 goes to the negative. In this case, output 2 goes to, I think I shuffled my pins. One way or another, pins got shuffled. The A and the 3 and the 4 got shuffled one way or another. And that's why it's negative instead. It's not too hard to just, I can demonstrate that here. If we change this to, if we go all the way up here in the code and we change this to a 10, this to 11, to swap these pins for motor C and D, these labels here, C and D, and then we start the simulation again, you can see that's positive and that'll be positive as well now. There's many different ways you can swap the direction. Very important to know just where these variables sit and why they are in that position. Okay, we added a second motor. Amazing. We have another 10 minutes to spare. Oh man. We can get extra fancy. We could leave it as it is. We'll probably not do any inputs today because there's a whole other thing dealing with inputs. So let's say a button, an ultrasonic sensor that measures distance, like such. Looks kind of like this. Looks like eyes. It measures distance. We use those in our Sumobot. There's edge sensors, which you can see here on the bottom of my bot. Basically, they work like very similar to the infrared receivers of like a hand dryer in a public washroom. You put your hand under it, it detects something, and it turns on, basically. Or it sends a signal to the microcontroller, which turns on the fan motor. In this case, we can make it do whatever you want. Edge sensors are, I guess you consider it binary, because it's either on or off. And it's very useful for sensing the edge, because I can show here, our little Sumobots are supposed to go on these little boards here, which are circular. And they have a very, very stark contrast between the middle of the playing field, which is black, and the white outline. And the edge sensor can totally detect that. Very nice. Very nicely, which is very useful. And maybe if you've done Lego Mindstorms or Lego First Robotics competitions like that, they usually have those black and white strips all over their track, so you can take advantage of that, which is quite handy. So yeah, I think that is everything as it stands. I'd like to, I guess, thank you guys so much for watching. John, if you want to take it away from here.
Wow, that was a really cool workshop and introduction, Luke. Thank you so much. You know what they say, you saved the best for last. You guys are fantastic.
Thanks so much.
Yeah. So to all the people watching, is it possible for new members to join York University Robotics Club right now? Sorry, Robotics Society, and then to take part in the challenge?
At this point, yeah, totally. And we also encourage people, now that it's more in person, I encourage people to partner up and work on a bot together, especially now that the competition will be after exams, right after exams. Haven't decided on a specific date yet, but at this stage in the game, you'll probably have to work a little bit quicker, so partnering up would definitely be recommended. But you can totally join. You can come to office hours. You can, they'll be virtual and online, virtual and in person. So you can join, ask questions. You can message me on the Discord, asking questions about what parts to buy. We have links and everything's spread or actually condensed in a very nice area in our Discord. So it's very easy to get started if you need to, for sure.
Awesome. I just posted the Discord link to the YURS Discord. And for people who have questions or would like to participate in the York University Robotics Society challenge, you guys can always join in. If you have any questions, please drop it in there. But that's it all that's a wrap from all of us. Thank you for joining in on the day 3 workshops. We hope to see you again for the next day, for day 4. Thank you everyone for joining in, and we'll see you tomorrow. And a big thanks to Luke and Mastafa for the wonderful workshop. Okay. Thank you guys.
See ya.
See everyone.